Hello, in this video I'll show you how to use region growing or fill region operations to segment different bone parts of the skeleton. So this is a mouse CT scan and we have a 3D fluorescence image here, and the segmentation could then be used to compute the uptake in different bones, for example. Or if you're just interested in CT analysis, you can compute different features such as the volume or the density of different bones. The software is called Imalytics Preclinical, and it is meant for analysis of multimodal image datasets. So this is showing you some result after maybe 20 minutes of work, but I will now just close that segmentation and start from scratch. So here you can see the CT rendering in 3D, and we can change that using the windowing dialog here, maybe make it a bit stronger, and then we can perform an initial thresholding operation. Let's just call it bone. And we say thresholding above center, that just segments what we see. And now we have a basic segmentation. Everything bright is assigned to bone now, and we can start to use the region growing operations. So let's add a class arm and right click in here, say for region unlimited. There we have the arm, here the other arm, and for the legs we would have to perform a cutting operation. So let's jump here and open a sagittal view, zoom in a bit, and then make a cutting operation here, and then add a class leg and perform a fill region operation. Now we have that leg. We can do the same for the other leg here, get also this leg here, and now let's call this big thing a temp here, so that is the remaining bones, and we can actually delete the old bone class here to get rid of the small stuff. So how to segment the ribs? We can also use the cutting operations, but let me show you the fill region distance bounded. So let's just add another class rib 1, for example, and then so this is maybe 1 centimeter. So let's just say fill region distance bounded 10 millimeters, and that flows 10 millimeters, but that was too much, so we can use undo and maybe go a bit further, and from here say fill region distance bounded 10 millimeter, again a bit too much, so we go a little bit farther, 10 millimeters. So now we segmented that rib, and let's create another class rib 2 and do the same trick, also 10 millimeters like here, and here add a class rib 3, 10 millimeters. So that works nicely. So let's now use the cutting again. Here we have the sagittal view, and there you can see the ribs, and by drawing the scribbles and pressing F2 we can cut. Multiple ones here, 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 and let's just add class rib 4, fill region, add class rib 5, here fill region, so that way we can quickly segment all the ribs that we have. So here they are also connected to the sternum. Let me show you again. Jump here and delete. So what I did to jump there was, you can maybe use this button, that's easier. Just activate it and click where you want to jump. What I used was the shortcut Control and left mouse button to jump. That's like an expert trick, and you can look up these expert mouse modes in this dialog here. Center view, Control, left mouse button is used to jump somewhere. Let me now show you how to use this fill region to segment the lung. So let's close the segmentation, turn on the viewing of the CD file. So the lung is dark. Here we have the lung. The intensity is around 300, whereas soft tissue is around 1000. You can see these numbers on the bottom right here. So let's add a temp class, temporary class, perform a thresholding below maybe 600, something between the lung intensity and the soft tissue intensity. Now all the dark voxels were assigned into this green temporary class. Now add a class lung. Here in 3D you can actually see the segmentation. There you can already see the lung. Now we perform a fill region in the lung to fetch it out. Here now we have the lung, and we can delete the temporary class, and here we have the lung in 3D. So let's go back to where we had the spine, because I want to show you another trick. I'm doing undo. Oh, that's it. Well, what I want to show is actually the find largest component here. So if you have multiple components, you can use this operation find largest component, and that gives you the biggest one of them. That may be convenient. And then there's also an operation here, find small components, where you can find all separated components below a certain volume. Okay, that's it for now. So thank you and goodbye.